Zachman Framework for enterprise architecture. Zachman Framework is one of the most popular frameworks in the world of enterprise architecture. In Zachman Framework for enterprise architecture is basically constructed in two-dimensional classification schema for prospective representations of an enterprise. It was derived through observation of descriptive design artifacts of various physical objects like airplanes, buildings, ships, computers, etc., in which it was impartially observed that the design artifacts of complex products, such as the prospective representations, the product descriptions and engineering documents, and so on, can be classified by the audience for the artifact in which is the abstraction. So it should be classified for the audience for which the artifact was constructed, therefore creating a perspective as well as the classification by the content of subject focus of the artifacts. Now let's start with the abstraction of the framework. All the columns in the frameworks, as you can see here, are the different abstractions or the Zachman framework. We start with the first column, which is called what. The abstraction depicts the independent variables that constitute a comprehensive description of the object. In the first column, which is what, it is made of the material composition of the object, the bill of materials for enterprise, and the things such as data, models, and so on. And so basically is about the function or the functionalities that the different parts of the enterprise architecture will be using, or the business is using. So basically is the functions of the business. Second column is the how, and then it works the functional specifications, the transformations for enterprise, the process or the functions of the processes for the enterprise. And it's talking about how the functionality of the enterprise is supposed to work. So the first column is the what, which is the function, and the second column is the how, which is basically based on the process of how the things are done in this enterprise. The third column is the where the components are located. So it's about where the components are located and relative to one another. The geometry, the connectivity for the components throughout the enterprise. So is for the enterprise's logistics, such as networks and so on. The fourth column is the who. Is about the who does what work, what kind of work. So is the manual of the operations, or is the operating instructions of the enterprise. Is about the people or the workflow of the enterprise, or the workflow for the model that we are implementing in this enterprise. The fifth column is the when, and when do things happen relative to one another. So it's a chronological succession of the events and then process of this happening. is the life cycle and the timing diagrams of for enterprise, and the time such as dynamics. So it's basically a dynamics models of the enterprise. And finally, the last column is about the why. And we're talking about why do things happen the way we design them to. And it's the ends of the means for the enterprise, and the motivation for this model that we are creating at this point. Okay, after the abstractions that we talked about, and we said all the columns on the top is depicting the abstraction, we talk about the rows in Zachman Enterprise Framework. Different perspectives are being represented over the process of engineering and manufacturing complex products. The descriptive representations of the products that are prepared over this process are designed to express concepts relevant to the various perspectives from the enterprise. That is, not only do the design artifacts depict the necessary engineering information, but they depict it in such a fashion that it is understandable to different audience for which they are created for. So the rows in this diagram or in this framework is mostly about different perspectives of different stakeholders throughout the organization, as in respect to different abstractions. In row 1, we're talking about the scope perspective. So it is about the scope perspective of the model, and it's about the context that establishes the universe of this course. So what is it exactly, the scope of this project, the inner and the outer limits of the project, and the list of relevant constituents that must be accounted for in the descriptive representation of the model for the remaining perspectives. Also, make sure do not add rows or columns to the framework. So this is really important that the framework stays as it is. We should not be adding any columns or rows to this, or probably cross connecting rows and the columns together. These are the primitives. That is, you must have all of them to be complete. They are also comprehensive. That is, additional interrogative, add no new information. So if you add anything else, you will not add any information to this model. That is, you must have all of them. In fact, additional interrogative columns or cells could introduce redundancies, which for classifications purposes is redundant. Second row is about the owner's perspective, the recipients, basically customers, users of the end product. For example, airplanes, houses, and so on. So it's the end product for the customers, so the users of these products. These descriptive representations reflect the usage characteristics of the end product, what the owners are going to do with the end products, or how they will use it once they got it in their possession. This is the conceptual view of the end product, whatever the owner can think about relative to its use. The third row is about the designers' perspective, the engineers, architects, the people who design this system. The intermediary between what is desirable by the owners in row 2 and what is physically and technologically possible to build in row 4. So this is something between these two perspectives. These perspective representations reflect the law of nature, the system or logical constructs for the design of the product. This is the logical view of the end product for the enterprise system. So this is the logical representation of the enterprise, which forms the basis for the white collar system, the rock keeping, or the bed of the manipulating tangible aspects of the enterprise. In row 4, we are talking mostly about technology. We're talking about the solution definition and development of these things. It is about the builder's perspective. It is about the manufacturing engineer. It is about the general constructor, the employer of some technical capacity for producing the end product. This descriptive representation reflects the physical construction or physical constraints of applying the technology in the construction of the product. Row 5 is about an out of context, is the built representation. It's about a detailed description that disassociates the parts or pieces of the complex object for manufacturers' purposes. This out of context representation plays a part in the transformation from the media of the design of the product to the media of the end product itself. For example, in physical products like airplanes, the medium of the design is typically paper and ink, or more recently electronic, medium, electronic design, artifacts, files, and so on. Whereas the media of end product itself is aluminium, titanium, and composites, and so on. So this is about the transition between the two. Out of context artifacts are employed in this media transformations between the media of the design and the media of the product for enterprises. These are the product specification relating the technology constraints of row 4 to the vendor products in which the technology constraints are materialized. In row 6, we are talking about the representations, the physical manifestation of the end product itself throughout the enterprise. Is the functioning enterprise, and it's about the evaluation of the end product. Although technically the row 6 is not an architecture because it is not the representation, it is the actual thing itself. However, it is useful to incorporate it into the framework, as it completes the architecture picture. For an enterprise employment of the framework, row 6 represents the functioning enterprise, and the end result of the architecture purpose. In other words, the end object is to ensure that row 6 represents what the owners have in mind for the enterprise represented in row 2. Row 6 is the realization of row 2, basically. Next, I'll talk about the rules applied to this framework. Of course, Zachman provided the following rules to assist the reader in understanding how the framework works, and what are the things should be done and what are the constraints of this framework. The rule 1 is the columns have no order. Order implies priorities and creates a bias towards one aspect at the expense of the other. In this framework, all columns are equally important because all are abstractions of the same enterprise. So therefore, the rule 1 is that columns have no order. Rule 2 is about that each column has a simple basic model. What does that mean? Is that each column represents an abstraction from the real world for convenience of description. This model includes things like data, function, network, people, time, and motivation, which is what, how, where, who, when, and why. Each column of the framework is descriptive of a single independent variable within the analytical target. In our case, the enterprise. Therefore, the basic generic model of any one column is very simple. The variable, in other words, the abstraction, represents as related to itself. Whatever variable represents is related to itself. So a single variable basic generic model in column 1 is about the thing, it's about the relationship of the thing. The column 2 is a how with process, is about input output process. Where is about the location, nodes in a network, lines and nodes. Who, column 4, is about people, their work and their relationship to each other. Column 5, when, which is about the time, it's about the event, it's about the cycle, and it's about a time frame of the project. And the column 6, which is why, it's about the motivation of why we do things, and it's about the end means. For example, the generic model for all of the cells in column 1 is going to be things, relationship, things. The generic model for all the cells in column 2 is going to be processes and so on, as I mentioned already. Rule 3 is about the basic model of each column must be unique. So the individual models may be related to one another because they are all abstractions of the same real-world enterprise, but each model represents a separate and unique concept. each cell model specializes its column generic model. The specific model for any given cell will have to be customized to the constraints, the semantics, vocabulary, terms and facts of the row's representative. Again, considering that the cell description forms the baseline for managing change, in other words, the meta model will have to express all of the concepts affected by change to that cell model. Okay, so rule 3 is the basic model of each column must be unique. You cannot have multiple interrelated model for every column. Yeah. The rule 4 is about each row to represent a distinct perspective. Okay, so each row has to represent a distinct perspective. What does that mean? This rule is most easily demonstrated by the business model, system model, technology model, which are every one of them are different rows, which represent the owners, architects, builder, and so on, these representatives. Each perspective is different because it deals with a different set of constraints. For example, the owner deals with usability constraints, both the functionality of the aerostatic and the functionality together, and the architect deals with design constraints, the law of physics or nature, and the builder deals with the construction constraints, the state of the art in model and the technology, so how it's actually physically constructed. Rule 5 is about each cell is unique. So you cannot have cells in different positions in this framework, similar or identical to each other, since each column has a unique basic model that makes each column unique, and each row has a different perspective. Therefore, each cell in the framework is unique. And Zachman, in this framework, periodic it's like a periodic table. So it's basically you cannot have two cells identical. So it's a periodic table for information entities. It provides classification schema for information entities, allowing different entities to be combined to provide different views of an information system and so on. Because each cell is unique in different technology and different graphical representations, they need different graphical representations because they are appropriate for different cells. So for every cell you need to have a different graphical representation because every one of them are unique. These also account for a large number of information systems design models and methodologies that have emerged over a number of years. Okay. Rule 6 is about combining the cells in one row from a complete model. Basically, every row represents a complete model for a particular perspective. So when you put them together, they will construct a complete model. So every row here is the complete model of the architecture, but for a certain perspective. So whatever we describing here is the same thing that we're describing here, is the same thing that we're describing in row 3 and row 4 and 5, but in different representation. Why? Because we have a different perspective. We describe our enterprise architecture for the owner differently from where we describe the same architecture for our architect, for our builders, for our network representatives. Okay, so let's see what are the rows in Zachman Framework. The first row is about the requirements, external requirements and drivers for the architecture, for the enterprise architecture. It's about the business function modeling for the enterprise architecture. Now, why we do that is describing the business goals, the objectives, and the performance measures related to each function. So we are telling the enterprise what are the motivations for every function and what are the goals and objectives we're following for that. In how we are talking about the high-level business functions is about a combination of basic atomic functions put together and created processes. So we're talking about business processes. In column what, we're talking about more of data or high-level data classes related to each other that create a specific atomic function. In who, we are talking about, obviously we're talking about people, we're talking about stakeholders, and we're talking about every specific type of stakeholders related to each function. If you have, let's say, 3 major functions or 3 major processes, business processes, what are the stakeholders concerned or related to those functions specifically? And the where is of course is talking about the geographical location of every node throughout the enterprise architecture, and the relationship to each function, and then how each function is placed physically in our network. And finally, the when is about the time, is about the cycles and cycles of events related to each function. So is the time constraint for the functionality, in other words. Row 2 is about the business process models. And we're talking about business function allocation, and we're talking about elimination of a function overlap and ambiguity. We are making sure that we don't construct multiple functions for the same purpose, that they do the same, they do the same business function for us. So the why in this perspective is mostly dealing with policies and the procedures, standards for which processes should be based on. So that's why what the standards and policies do. They make sure everything is done in a uniform and efficient manner to avoid duplications and to avoid wastage. In terms of function, it's mostly a business process function. In terms of data, it's about the business data. In terms of who, is about the roles and the responsibilities in each process. And also in terms of location, is about the relationship between the physical location in the network and a related process. And the timing is about the event for each process and sequencing of integration and process improvement throughout the organization. In row 3, we're talking about logical models, project management, requirements definitions. For the why, which is the motivation, is mostly again about policies, standards, and also is about association of those procedures and policies with the business model or the business rules model. In terms of functionality, is about the logical representation of information systems and their relationship throughout the organization. So we are talking about, or we are looking at the architecture or architect's view of the enterprise. Therefore, it is for them important, what's important for them is the information systems relationship throughout the organization. In terms of data, which is the what, we are more concerned in this row with the logical data models of data and data relationships underlying the information. So how this information is constructed, or what are the data that they are needed to construct the information systems. People is about the logical representation of access privileges, for example, or constraints by roles and responsibilities. Is mostly about the security and authorizations throughout the information systems in the organization. For example, who have access to what is one of the questions that this cell is supposed to be answering. Of course, the where is about the logical representation of the distributed system architecture for different VI location. And the time is about the logical events and their trigger responses constrained by business events and their responses. Right? Row 4, we are concerned with the physical model. These are the builders. These are the people who are going to choose technology and to manage the technology throughout the organization. They are talking about the solution definition. These are the people who are getting the architect's instructions on the design artifact and provide solutions for different small pieces of the enterprise. So the solution design happens and development happens in here. The motivation is mostly business rules constrained by information systems standards. We're talking about what languages we use for particular software implementation, of what kind of hardware and software components are needed throughout the organization. These are the standards we need to figure out. Then we're talking about the functionality in this row, which is the specification of applications that operate on particular technology platform. The data is the database management system. We choose different DBMS, RDBMSs particularly for a particular solution throughout the organization. The people are about the specifications of access privileges, of specification platforms and technologies, and of course the network is the specification of network. As you can see, everything here is mostly about specifications, because we are designing specific solutions for different information systems designed by the architectural level in the row 3. And the time is about the specification again of triggers or response to the system events and specific platforms and technologies. Row 5 is more about actual build, actual delivery of configuration management, how we deploy our bits and pieces throughout the organization. The motivation is the business rules constraint and specific technology standards. Is about how is about the programs coded to operate on a specific technology platform. The data is mostly about data definition, actual definition, and physical data models. Is about who were the people in this row are mostly about access privileges coded into control accesses and specific platform and technology. And the network is actually the devices configured to conform to the node specifications designed in row 4 based on the solution on row 4, and the row 4 based on the solution on architecture in row 3. And of course the timing is the definition of coded to a sequence activities exactly one after another. The row 6 is mostly is not really a separate model by itself. Is basically what we've built, is the functioning enterprise, is the operations management, evaluation. In this phase we need to know what have we done, what it is we've created, and evaluated to make sure that it is conforming to the specifications in the row 1. So motivation is the operating characteristics of a specific technology, constraints by standards. Functionalities is the computer, functioning computer instructions. Data is actual the value stored in the database itself. People are the personnel and the key stakeholders working with their roles and perspectives, and the network is sending and receiving messages. Basically a functioning enterprise is what we're concerned with in here. Okay, so this was the Zachman framework in a nutshell. Of course this is a much more details left that we left out and we didn't say here, but I think this session was pretty compact, and all the necessary things that we need to know about the Zachman framework was discussed here.